starting to fill in now. Welcome everyone to the webinar, Synapse Analytics. We will start shortly, just waiting for everyone to hop on, and then we will begin. So throughout this webinar, we will have the live chat available. You can send in any questions that you may have or any comments, and we will definitely round them up at the end and try to get through all of them if we have the sufficient time. And we also would like to thank those who are joining us from Egypt. You're joining us on a day off, I suppose, and it means a lot to us. So thank you very much.
All right, so I think, Marwan, let's start.
Sure. Let us begin. So welcome everyone to the Synapse Analytics webinar, going about AI in your business. We're very happy to be here today with you. It's going to be very exciting. We're going to keep it as informative and simple at the same time. But before that, I'd like to present myself and I'd like to present the team so you guys know who are your hosts for this webinar, and give you a little brief about Synapse and what we do and the projects that we are working on and so on. So my name is Marwan El-Iskandrani and I am the AI Territory Manager at Synapse Analytics, which means I basically handle the sales and business development of the company. And I'll leave the floor to Ahmed to continue his introduction.
So I'm Ahmed Abaza. I'm currently the CEO of Synapse Analytics, and it's very exciting because this is actually our very, very first webinar. And we try as much as possible to achieve, like what we want to achieve this time is we try to stay away from anything that makes AI complicated, because we probably know that many of you have heard a lot about artificial intelligence, about how it can get really overwhelming with big data, analytics, supervised learning, and all of this stuff. So we try as much as possible to make it as distilled as possible. And we will try as well not to go deep into the technicalities of it, but mainly we're aiming for building more of a frame of thought to be able to initiate and frame machine learning work. So Marwan and I are joined by Mohammed Abaza as well. So Mohammed, can you please introduce yourself?
Hello, I think I'm Mohammed Abaza. I'm work as the innovation manager and product design developer. You can say I have a lot of functions in the company, and I'll be overseeing the technical aspect of this webinar. So asking the questions and getting to the polls and everything. So please, if anyone has any technical difficulties, please let me know through the chat.
Yeah. So as Mohammed said, if you have any questions, please put them in the chat, and Mohammed will be regularly reading them to ask us in the webinar. So the reason why we're having everybody is muted, because we don't want when there's a lot of people coming in, there might be a lot of distraction with everyone speaking and so forth. So we decided to go with your questions in the chat, and then we can read them out loud, and Marwan and I will be answering them. And if it goes in the technicalities and so forth, Mohammed will also be answering these questions. So without further ado, let's begin. So first of all, when it comes to artificial intelligence, what are we solving for? So what does AI basically do? And like in a very, very small statement, artificial intelligence algorithms, what they do is they bring out a mathematical formula. And this formula, basically, it tries to map inputs to outputs. So, for example, if we give it inputs of housing data and housing pricing data, what happens is, based on the housing features or housing descriptions, like how big is the house, where is it located, how many bedrooms does it have, how many bathrooms does it have, and then what it does, the algorithm would spit out a formula, a mathematical equation, to be able to tell the pricing of this house. So for example, you want to know the exact pricing of a certain apartment in downtown Cairo, for example. What it does, you ask the algorithm, and based on the data that the algorithm has been trained on, it can output an accurate price of this apartment. How much will it cost? How much will it cost you to buy it? So there is a bit of something to declare here. Like, when given this data, the algorithms are very powerful in predicting or in basically estimating the right price when it comes from a similar distribution. And this is a big problem when it comes to AI. So for example, if you want to predict the house prices of downtown Cairo, and then you go to Madrid, for example, and you want to predict housing prices there, it's not from the same distribution. So when I speak about statistical distribution, we mean from basically similar, more or less similar data. So if you want to predict a house price in Madrid, and you're training data which the algorithm has been trained on or has been exposed to come up with the formula by which it can predict the house prices, it wouldn't be as accurate in Madrid as it is in Cairo, because the data is different. Another example on this may be if we use, for example, AI algorithms to detect faces and to detect men's faces. So we get training data of thousands of data points on men's faces, and then show the algorithm a woman's face. It might not be able to know that this is because it has not seen it's outversion of the data, so it cannot actually tell if this is a woman, because it has not seen any women before. So this is a very simple example of what we mean when it comes to distribution.
So I think, Ahmed, you mean by this, you mean that if you would want to have the same pricing model in another country, for example, you can apply the same principles, but you have to tailor it a little bit to the different market that you go into.
Exactly. So in that case, you would have to expose the data of this market to the algorithm. Now, many researchers are working on what's called general AI. And general AI is basically how you can generalize an artificial intelligence algorithm to be able, for example, to predict house prices everywhere in the world. Though, of course, this is a very, very difficult problem, because you require a lot of data from every little place in the world, and consumer behaviors and real estate behavior changes from a place to another. So that's AI. So what AI solves for, it can look at some data, and it can map, basically it can see the correlations between the inputs, like as I said, housing, how big is the house, how many bedrooms does it have, and be able to correlate how these inputs impact the output, that is the price. So that's what AI in general, this is how AI in general works. So let's go to so as I said here, so basically you bring in the data and you get this data into a model. So a model is, you can say, a frame of thought, for example, for the algorithm. You combine both together, and then an output algorithm would come out. So what happens is, this output algorithm, what it knows, it can, based on the correlations and based on how it saw the patterns of, for example, how many bedrooms and how it affects the price, it can now spit out, if you give it this house location and the number of bedrooms, it can foresee or it can predict the price of this house. So let's see a sort of algorithm in action. So basically, as you can see, this maze, if I give this maze to any person attending here, it would probably take you 5 to 6 minutes to be able to reach from point A to point B. Now, with an AI, let's see it. Let's apply this to an AI. Let's apply AI to this and see what happens. So as you can see here, the AI actually did what most of us would do, right? It tried different routes, and finally it found the best route from point A to point B. But it took a fraction of the time that it needs a human being to do so. And this is where artificial intelligence comes into play. When you're working in your business, when you're operating in your business, you're usually amassing a huge amount of data, and you're amassing like data from your customers, data from your products, data from social media, data from even videos from your CCTV cameras, from your POS systems. And you cannot, like, as a human, you cannot basically correlate all of this data together, because it requires a lot of work, and it requires a level of detail that maybe it's not found basically in our ability to look at this data all at once and be able to generate models that can accurately give us insight on how to operate our business. This is where machine learning actually comes into play. You just give it the data, you put in a model of thought, so like a frame of work on how it can look at this data, and it can generate an algorithm without being explicitly programmed. And here by explicitly, I mean, like with standard software programming, you usually write the code, you write every little step that the code has to take to be able to generate this output. With AI, it generates this automatically. So I'll leave Marwan to tell us a little bit about like an example of a problem that AI can solve really efficiently. So Marwan, you have the floor.
So I would like everyone to imagine for a second that you own a store, for example, and this store can be anything. You could be selling fashion, like clothing items. You can be running a restaurant, or really anything in between, any retail outlet. So imagine how many steps you have until you serve your customers. So it starts at the very beginning when you are ordering your, let's say, supplies. If you're running a restaurant, you're ordering your ingredients, your raw material, your plates, your cups, and really anything that you need to run your business. And then the second thing you would think, okay, maybe how many waiters or how many cashiers do I need? How many people do I need running the place? What's the how many can I serve at the same time, given the space or the resources that I have, the assets that I have. Given the assets that I have and everything in between. So we need to take a look at all of these together. But the problem is that it's not just these items or these things that you need to look at. You also need to look at things like, what's the weather like today? Does it affect the number of people coming into my restaurant? I have to check, the macroeconomic data. If my consumer price index, does it affect my sales or it doesn't? So you need to look at a variety of things. One of them is the historical data, the transactional data. And by the way, guys, if you have any questions, please ask them and write them right away. The historical data, you take a look at the macroeconomic data, the weather data, and anything really in between to understand really what are the leading factors that will push my business forward, to understand really the impact of every single feature that exists on my operations. So for example, imagine you have a very accurate metric of every single dish that you're about to serve, and you can really predict how much of the, let's say, hamburger you're going to sell in the coming month. Then if you have that, then you can really predict how much buns you need, how many patties you need, how many ingredients of every single thing you put on that burger. So not only are you predicting how many of those you need, but you also understand you're not under supplying, you're supplying at the exact right amount. And when you understand the demand on your branch as well, you can start to think, okay, how many waiters do I need? I need this much to cut my costs, but also serve all the customers that are coming in. And that's only talking one store. So imagine you have 40 different branches across, the entire nation. Not every store is going to be run the same way, which goes back to the statistical distribution that we were talking about. It's very hard to have a general, model that predicts for everything. You need to really tailor it to individual needs of every single branch that you have. And keep in mind when we're going through this webinar of all these things we could look at to accurately predict the outcomes that we can get.
So, so as Marwan said, basically, this is what we say when it comes to AI optimization or AI deployment. We look at these 6 themes to be able to brightly frame an AI project. So, for example, cash allocation. And this is where you like Marwan said, you're buying the right product at the right amounts at the right time, so you're not overstocking or understocking, so you're not losing merchandise that's sitting there in the inventory and not moving, and at the same time you're not losing on sales opportunities. Another theme is people and labor, because many times you can find how people like working hours, for example, like a certain branch working from, for example, 9 to 6, and maybe if it works from 6 to 12, it's not that effective. So you can you can optimize your labor time or your working times based on how you can run your stores effectively, for example. Or for example, some people are much better at selling a certain product. So all of this can come into play where AI can correlate how people and sales, for example, are correlated together. Time effectiveness is, of course, a major thing, because especially when it comes to planning, many companies take month and month to plan budgets, to do the right forecasts, to do all of that stuff. And AIs, like the maze, it can do it in a fraction of the second if it's optimized correctly, if it has the right data inputs, if it has the right models with the right integration. Time can be taken from several days, maybe months, to a few, and I'm not exaggerating, to really a few minutes. So when it comes to assets, for example, if you have a fleet, if you run a manufacturing company, if you're a manufacturing company, you can see how you can reduce the downtimes of your machines, plan changeovers, all of that stuff, as well, using AI by doing demand forecasting, by doing, by actually optimizing the variability by which your raw material comes in, and so forth. And of course, growth and revenues. So growth comes when you can optimize your marketing campaigns, you can target the right people. AI, all of these are AI applications. Maybe you do recommendation engines, for example, and I understand that recommendation engines are usually associated with e-commerce websites and so forth, but actually don't have to be an e-commerce website to utilize recommendation engine. And we actually had a use case where we actually applied it in a brick and mortar store without using any without them having any e-commerce websites. And of course, all of this would definitely affect the profitability of the business at the end of the day. So these are some themes that can help you start on thinking how AI can be applied, and these are the frame of work that by which AI can be utilized to optimize the business.
Now, Ahmed, we have a question.
Yes, please.
Here, do you want to take it now, or should we leave it at the end?
No, let's take it now.
Okay. How do you know if a certain problem can be solved by AI?
Okay. So how can you know if a certain problem can be solved? So let me rephrase the question. So how do you know that this is an AI problem, right? And please, whoever asked the question, let me know if that's the correct way to frame it. So, okay. So basically so AI requires two main things. So you need to have data, and you need to have the right model. And for example, something like the recommendation engine, you need to grow your business better. So for example, you have or you need to liquidate more cash, for example. So you have in your store, you have fast-moving products by which these products the turnover is very high, and people are buying these products really more frequently. And then you have products that are not bought or purchased as frequently. So what you can do is using artificial intelligence and using basically associative learning, you can associate these products together. So you can see, for example, if this product number one has a high probability of being sold with product number two that is fast moving, you can couple them together and do a promotion so you can liquidate more cash. So when it comes to framing AI problems, we'll come to it like within this presentation. And then please let us know if this actually answered your question. So for now, let's go through the very quickly through definitions. As I said at the beginning of the webinar, we try as much as possible not to go into like the terminologies and complications that the AI field is filled with. So, but there are some basic terminologies that has to be known just to be aligned with what machine learning is and how it can be applied. So machine learning and artificial intelligence usually are confused together and are very much and very frequently used interchangeably. So artificial intelligence is usually associated with systems that can get data input and can act autonomously and adapt to situations differently. And machine learning sometimes is used to refer to like giving output and like the user himself actually takes the decision. So it's not an autonomous system as it's usually referred to. Though, as I said, both are used interchangeably and both are you can say AI on machine learning and vice versa. So it's so this is one of the main distinctions that differs artificial intelligence and machine learning. And then comes deep learning, which is a subset of machine learning. And deep learning, basically, it uses neural networks mainly to be able to perform this output. And neural networks has evolved greatly in the last few years, and it's one of the biggest and most exciting areas when it comes to artificial intelligence. So this is just to distinct between everything and the terminologies and so forth. And when it comes to data science, and some people say, what is the difference between a data scientist and a machine learning engineer? And the answer to this is understanding basically the nature of machine learning and artificial intelligence projects in general. And interestingly enough, when it comes to modeling an AI or writing an AI algorithm or a machine learning algorithm, it's usually just 10% of the project, and 90% of the project has to do with data wrangling and data pre-processing and coding that has nothing to do with AI, actually integrations, maybe doing some sort of data cleansing and all of that stuff. So when it comes to machine learning is usually a tool that's usually found in the toolkit of a data scientist. So what a data scientist does, basically, we can categorize their output into 4 main themes. So the very first thing is descriptive analysis. Descriptive analysis, basically, when a data scientist can tell you what happens. So when's the most traffic coming to your store, for example? How many pieces of this product have you sold? How are people talking about your brand? All of this falls under descriptive analysis. Now, diagnostics is when you diagnose a certain problem. So why it happened? Why are people not buying this product? Is it because it's not found on the shelf, or is it because people are not very much into this product, or maybe it has bad reviews on a certain website, so people don't want to use it? So the data scientist has to basically they answer the whys of why this is happening, not only what happened, but actually why it happened as well. Now, the third theme of a data scientist's work is when it comes to predictive analysis. So they basically build models that simulate the future and can tell you what will happen in the future. So, for example, if you spend this much marketing and if you have this landing page on your website, they can predict how many visitors will convert into customers or users of your app. Excuse me. So this is the predictive part, and this is actually the most interesting and the most exciting part about the data scientist's work. And this is where machine learning is actually utilized a lot. So in everything I said, like in descriptive and diagnostic, they can also use machine learning. But basically, when it comes to predictive learning or predictive analysis, it's very much where a data scientist shines. And then comes the prescriptive analysis. And prescriptive analysis is basically one of the most important things, because if you do all of this analysis and it's not useful, it doesn't have any benefit. So a great example I like to give on this part is Google Analytics, for example. So everyone in the world has Google Analytics built into their websites, but a very, very rare percentage of the population using Google Analytics can actually transform it into actionable items that they can work on to increase conversions, to increase product sales, and so forth. So all of this is part of the data scientist work. Now, another very, very important distinction when it comes to business intelligence and data science, because this is usually very much confused. These 2 areas are very much confused together. So when it comes to business intelligence, we usually say it's more of query analysis, or query, by which I mean it has to do more with reports and descriptive analysis. How many when you have a database of items, so it can count the items, it can count the day when you sold the items. It has to do more with the descriptive analysis. And you can find a lot of data analysts and business intelligence softwares that are found in the market. Though the problem comes when you confuse business intelligence with data science. So data science is more exploratory. You can find correlations, for example, between weather and product sales. You can find how two products are correlated together, or how two products, for example, affect each other's sales. They usually work a lot with probabilities. They work a lot with prescriptive and predictive analysis. So this is basically a very important distinction between what a data scientist does and what a business intelligence individual does.
But Ahmed, it seems also that the data scientists, you said that machine learning is one of their tools that they use during any project, but it also seems from what you're saying that a data scientist also has a sort of business intelligence mindset as well. Is that correct?
Exactly. Though with most cases, usually a data scientist partners up with a domain expert to be able to frame the right frame or the right model to be able to solve the problem. And we actually had a case, Marwan, if you remember, the one with the online ordering app.
Mm-hmm.
Can you please tell the audience what happened and take them through actually why domain expertise is very important? This is, I think, a good example to give here.
Yes, sure. One of the use cases we were working on is when we approached the client, we really had, as Ahmed said, the data science expertise and the IT or the infrastructure expertise, but we didn't really have any idea of how the actual business was working. So what we did is we partnered up with them, and basically what was happening is we took a look at the data from the medical records of this certain company, and what we had to look at was the performance of Ahmed, are you referring to the hackathon that we were talking about? Is that correct?
Yes.
Okay, perfect. So a while back we were participating in this hackathon, and this is really where the difference between understanding the problem and just understanding how to code really shines. The problem was we had to get the likelihood of an individual to order again from the same, let's call it restaurant or delivery, food delivery place. And they had to predict what are the metrics that most affected the likelihood of a certain individual in ordering again from that particular place. And what were the leading features, or what did we find? That most participants actually said, you know what, if there's Wi-Fi and there's TV in that particular chain or particular branch, then the likelihood of reordering online will increase. And if you think about it for a second, what does having a TV or a Wi-Fi have to do with a person's decision to order or not from a particular place? And this is something that we noticed right away. And this is the difference between actually understanding the problem itself and understanding the framework and how to frame a problem, and just going into something and finding correlations. And this also leads us to something very important that we talked about before, that causation does not equal correlation. Sure, maybe having a Wi-Fi in the branch or a very good TV can increase can be associated with an increase in ratings in that particular store, but it doesn't mean that that's the reason behind the increased demand on that store.
And this is actually, Marwan, as well, this is part of where the danger of machine learning comes in, because any machine learning algorithm that you put in with data will result in a certain output. So having the critical thinking and how to criticize a machine learning algorithm is extremely important when it comes to AI and machine learning deployments. So here are the problem types for the gentleman who actually asked the question. How can you frame a problem for AI or for machine learning?
I'm sorry, Ahmed, to interrupt.
Yeah.
We have a question regarding the example, the hackathon. How did the AI know that there is Wi-Fi and TV?
Because it was labeled in the data. So part of what the data scientist does actually, and this is a great question, part of what the data scientist does is removing any feature or any data points that doesn't make sense. And usually this comes from the domain expertise. So the data had TV and Wi-Fi, which is data that's being collected by the app itself, which sometimes they collect it maybe for market research purposes or any other kind. But when it comes to predicting the likelihood of a customer ordering online from this certain restaurant, TV doesn't come into play, right? Because they're ordering probably when you're on the app. You're not looking if this restaurant has a TV. You're more looking into the cuisine, into the reviews, all of that stuff. So actually, when you put TV into the model, it actually confuses the model. It can think that having a TV in the store increases the likelihood of buying from that store. So this is very important to take care on. That actually, when it comes to data quantity, if you have more data, yes, it can be proved to be very useful for algorithms, and at the same time, it can actually confuse the algorithm. So, and this is where sometimes, because artificial intelligence are not, at the end of the day, are not that intelligent. This doesn't mean that it's not a useful tool. It's a very, very powerful tool, and it's a big leverage for any business to have. Though sometimes you have to take it by hand, step by step, right? You have to show it the way in a very step-by-step mode. Now, when it comes to problem types, what are the main problems that you can put AI to work on and actually providing a beneficial output? So the first problem of AI is predicting a value. So for example, as I said, with the predicting the house prices, you want to predict house prices. For example, are house prices going up or down? So if they're going up, you can actually buy a house and maybe don't sell it because you see there's an upward trend in the prices till, for example, an algorithm can predict now it's starting to go down, and then you can set the price at this point. Predicting demand and sales, so you can predict how many SKUs or how many of a certain product you're selling, and what are the most leading factors that affect the sales. So when I speak about leading factors, basically I speak about the factors that by having them you can affect the output. So for example, in the summer you sell more bathing suits, for example. So here the summer is a leading factor to the bathing suits sales. Optimizing price point, predicting commodity prices or stock prices, predicting conversion rates, all of this basically comes into the problem of predicting a value. In the terminology of machine learning, it's called regression problems. So basically you're predicting a certain value using regression algorithms to predict accurately how this value behaves. Now, the second problem is categorization. You want to categorize a certain class to a certain element. For example, customer segmentation. Usually when it comes to customer segmentation, people segment their customers based on maybe 2 or 3 features, 4 features like age, location, demographic. But with AI, you can actually segment on so many features beyond description. So maybe you can segment customers on how many times did they come to the app, for example, how the time they spent on the app. And then you can categorize on many features, and you can categorize your customers on like, instead of having 2 or 3 classes, you can have, for example, 8 classes. And this can help you a lot with personalized marketing, personalized targeting, and all of that stuff. Another use of the categorization problems is hire or not hire. So you get a lot of CVs applying to your company, and you can have you can verify or you can scan these CVs using an AI, and then the AI would tell you if this is a good candidate or not. All of that falls into the categorization or classification problems. Now comes another thing, that is knowledge extraction. So these are terms that we basically try to come up with to make the things, to make the problem type becomes more tangible. So knowledge extraction, basically, you want to extract a certain knowledge from, for example, text, like sentiment analysis. So you want to see how people are liking your brand. If you get reviews, are these reviews positive or negative? Knowledge extraction as well comes from, for example, extracting knowledge from images, like receipt data or video data. You can extract knowledge about traffic from video cameras. Quality control is actually one of the exciting parts of knowledge extraction. So many people are now playing with when a product comes out of the production line, you can have pictures of this product, and then the algorithm would tell you if there are defects or not in this product. And then the fourth theme is generative models. So you want to generate an output out of a certain input. For example, you give it a picture and you can generate a caption. So this picture has mountains, this picture has people, this picture has cats, dogs. All of that can happen from a generative model. Also machine translation. You can translate from Spanish to English or to Japanese using machine translation, and this falls also under generative models. Deep fakes. I'm not sure if you saw the Obama video where you can see him talking and speaking a completely different script from the one he actually told. It's a very interesting video. I think Muhammad, can we send this video to the audience after the webinar? I think it's very interesting to see how AI can actually work on generating a completely new video from an old one. And for example, another very interesting application is coloring black and white movies, and this is an application that's being used a lot now in coloring, or actually providing high definition old movies from old black and white and pixelated movies. So these are please.
While I'm pulling the video up, can you? There's a question. Would you please select one of them to elaborate more, like hiring the right candidate, for example?
Can you come again? I'm sorry, I lost you for a bit there. Can you come again?
Can you elaborate more on one of the examples that you've mentioned? And for example, like the hiring the right candidate one, how would you go about doing so?
Sure. So, for example, this is actually very interesting because also, I don't know if you heard about the Amazon algorithm that was biased against women. So basically what you do is you have a lot of employees, you have a lot of highly performing employees. So you just collect data about them. For example, their background, how old are they, what are their experience, and what did they do in their lives. Maybe they joined an active working group while at the university. Maybe they are an athlete. Maybe they are married or not married. So you collect as much data as possible. And maybe they worked at a certain company and so forth. And then you take all of this data from all the employees and you start labeling who are the best performing employees that you have, right? And once you have that, you show it to the algorithm, and then the algorithm develops a logic on being able to vet a new candidate when he comes in or when she comes in. And then the algorithm can tell if this person is going to be a better performer than others or not. When I speak about the Amazon case, the algorithm was actually biased against women because, like most, at the end of the day, there is this joke that goes when a machine learning algorithm goes into a bar, and then the bartender asks him, "What are you taking?" He says, "What everybody else is having." So this is the problem of bias in algorithms, because comes from algorithms being trained on on your judgment. It's mimicking your judgment, because when you tell that this person is a great performer, so the algorithms is biased towards your judgment. So it doesn't judge by itself. It understands that you see this person with this certain demographic or a certain background is well performing. So it kind of biases its decision for the next new candidate. So you have to be very careful in vetting your methods and vetting what is a good performer, what is not a good performer.
And Ahmed, I think this also ties into what you were saying about AI. That's why it's called artificial intelligence, because at the end of the day, it doesn't know that it's being biased, or it's biased towards a certain, demographic.
Exactly. And this is why, for example, maybe in Amazon, like most best performing people are men. So it was very, very against. So it had like a leading feature of being a good performer is your gender, which is, of course, doesn't make sense as well. So this is why it was very much biased against women. So they actually stopped using the algorithm.
Mhm.
It's actually a great article as well. I think Mohammed can actually send the audience the article. I think it's a great read to have. So Marwan, can you tell us a little bit about
Yes.
regression model use case?
So after what Ahmed explained, the difference between regression and classification is that usually, or all the cases that of regression, they deal with numerical values, okay? And classification, they deal with an output that doesn't necessarily have to be something numerical, like a recommendation engine, right? So if we take a look at a regression model, one of the most important use cases for really anyone that's selling anything is how can I optimize my pricing? And one of the methods is called dynamic pricing, right? So what are the factors that can affect dynamic pricing? Things like seasonality. When am I selling this product? Am I selling it in the summer? Like Ahmed said, you know, it's, when summer hits, everyone's starting to buy swimming trunks. Is it a low season? Maybe I should reduce the price. There's not a lot of demand on it. Maybe, you know, at certain times throughout the day, maybe at night, I'm not really selling a lot, then maybe I should bundle it with something else. So there's really a lot of things we can look at. And actually, one of our use cases that we were doing related to dynamic pricing is it's one of our clients here, where we actually took a look at the least well-performing items and looked at the best performing items, and we priced it according to how fast we want these items to move. Basically, we don't want it to last for such a long time on the shelf that it would either go bad or just, you know, go obsolete. But we would somehow tie it or price it in such a way that people who usually buy item A, they also buy item B. So that's a pretty good example of how you can dynamically price your stuff. And if you have something like an AI model, you really don't need to focus on adapting and updating the algorithm as you go. It does it on its own. So for example, if you have an e-commerce website, it knows, it has all the inputs already, and these inputs are being constantly updating, so it can give you different prices right away. And this is exactly like what Uber does, like what Airbnb does, and it's been around for ages. Like when you call if you want to book a reservation at a hotel or something, this is how they do it. Although maybe it was done manually before, but now you can put in so much into the algorithm that it can really predict the right price that will ensure to a high degree that it will be sold later on. And if we would actually look at the second example of this regression model, the second example is how hedge funds, or these are funds that invest people's money basically in a very diverse portfolio, how these hedge funds outperform the traditional hedge funds. And what it means is it takes the money, it looks at the performance of so many different companies, so many different stocks, what the market looks like. It compares macroeconomic data with the performance of, you know, the stock of this company, and it bundles all of this up together. It goes into the algorithm, and then it yields a prescriptive action, like we talked about earlier, if you guys remember, prescriptive action on what I should invest in, and it does so automatically. And there are companies now. That exist that operate, you know, basically solely on the idea of there's no human interaction, there are no emotions in any trade or any buy or sell that happens. It's just the computer performing the tasks. And this is why the numbers in front of you, they showcase that, you know, as time goes by, these hedge funds, these AI hedge funds really outperform the regular hedge funds. So let's now take a look at the classification model or classification use case, right? So we said that the output doesn't necessarily need to be something numerical, and I'm sure everyone right now recognizes the screen in front of them. This is the home screen of Netflix, essentially. And I'm sure you guys probably know that there's some sort of recommendation because it says, you would like this. But the extent of the recommendation is it's quite detailed when you break it down. It actually not only recommends titles that you would like, it also shows you the images or the posters that would make you click on the show. So that's why maybe I can look at the show on my account and then on another friend's account, and we would have the same show but different posters. Sometimes even we were reading about this earlier. The Netflix maybe can recommend you shows where the main character is left-handed, just because it noticed that there's this feature that affects maybe people like me in my subgroup. So this is the extent of how categorization or clustering can work in essence. And this is being also done everywhere. When you take a look at things like Netflix, things like YouTube, that's why I'm sure it's not only me when you go into a video and you spend the next 5 hours stuck in a loop, not being able to exit just because you're so into what you're watching. So now let's take a look at something more, related to knowledge extraction. What is knowledge extraction? Basically, imagine that you have you own a mall and you would like to know how many people are going in, how many people are going out, where are they distributed, which parking spots they're parking in, and which entries they're coming in from. And this is exactly it. This is called customer footfall. And you just using the camera that you have, you can actually pinpoint exactly the amount of people that currently are in your building. And this is the screen that you guys see in front of you right now. At every single instantaneous moment, you can know exactly how many people are coming in from the parking, how many people are coming in on foot, by car, at every instant. And then you can recall these to take further actions later on. And this is just one example. And another example of knowledge extraction, which is very useful for our retail example, is the next slide, where what if you want to have some sort of monitoring system that tells you exactly how many products you have on shelf and compare those to the products that you have in your inventory, and maybe you want all of your products to be aligned perfectly for the customer experience when he walks in and sees those, and it looks beautiful and everything is organized. This is also something that you can extract with the video feed or the photo feed that you have. This example shows you that the machine accurately identifies each and every product that you have, because we've spent the time, we've labeled it, and now the algorithm knows. So for example, we can deploy something that says, oh, the one on the extreme left is not really aligned. Send someone align that. And then it can say maybe, oh, there's a few empty spaces in front of those cans. Check the inventory and stock up on those empty spaces. This is key for the retail experience, essentially, because this is what they already do. But there's no way, or it's very time consuming and energy consuming to do it manually and to check each and every row or each and every shelf for that particular instance.
So I think, Mohammed, let's take, before we go into the next part, let's take 2 minutes for questions. Do you have any new questions?
Yes, we have 2 questions, follow up on one another. The first one is the biggest challenge is to get accurate data. Many companies are not ready to implement AI solutions because they are not ready with prerequisites and cannot avail comprehensive quality data. How are you tackling this? And we have Abanob, he followed up on
okay, so let me first get to that, and then we can move to the next question. So actually, it's right on point, because now this chapter or this part of the webinar will be talking about data types. So now, when it comes to accurate data, that really depends, because you can say that every business in the world has a sample of the data. So no one has actually super accurate data. So it depends at the end of the day on the use case. So for example, if you want to, and on the generalization of how general you want your model to be. So for example, if you want, like I said, if you want to be able to predict the house prices of houses in Madrid, then you have to have a training data that follows the same distribution of the house prices in Madrid. It doesn't have to be 100% accurate. So actually, when it comes to data, a lot of what the data scientist does in modeling the data itself has to do with handling missing data. No business in the no use case, not one client that we ever worked with had the right data quality from the get-go. So you have to have certain things. You can start with a good enough model that works on certain predictions or certain optimizations, and then as you go, you're collecting the right data that can improve the model as you go. So for example, maybe in the first 3 months you reach a 70 or 60% accuracy in, for example, predicting a certain SQ performance, and then as you go, you start experimenting a lot till you and you're continuously improving the performance of your algorithm till you reach like a very, very satisfactory output. Now, this is a great question because this brings us to the nature of data science and machine learning projects. It's never a one-time thing. You're not getting into building a website or building an application that once it's done, it's done. Like it's always evolving. You're always experimenting. You're always collecting new data points and bringing these data points into your algorithms, and then seeing how these algorithms behave. Now, a very interesting thing that happened to this question: usually, data has a shelf life, and this is something that every business has to know, and many people don't know that. And like this Corona phase actually proved it to be so correctly. So any algorithm that was trained on the past, for example, 10 years, at this phase, these algorithms, I would suggest that they're completely out of place, because now we're in a time where consumer behavior is completely changing, and the data, the historical data, is no longer valid to deal with what's happening right now. So how do you do it? You're now collecting new types of data. You're now doing certain assumptions that weren't taken into consideration in the past. You're doing scenario-based analysis. So, for example, you're following multiple scenarios, and you're basically playing with parameters, and there's a degree of acceptance. There's a degree of how much would you accept this accuracy to be at a certain use case, and then deploy it and work with it till it gets better and better as you go. So data accuracy or data integrity is an always evolving thing, and it's a never-ending process. How do we deal with it? As I said, so basically you make assumptions, you fill in data you find, for example, maybe correlation with another data set, and you bring it to your data set. So for example, let's say you're selling Pampers, for example, and I'm not talking about a certain brand here, so this is just for example purposes. You're selling Pampers, for example, and somehow you see like basically you're trying to predict your demand, and it's always falling out of line. It's not accurate, and for example, sometimes the algorithm brings out a certain demand forecast that is completely out of bounds than what's happening. So you underproduce or you overproduce. Then you get a data set that has to do, for example, with maybe like how many people are buying maybe refrigerators, or how many people are, for example, buying SUVs or something in a certain area, and then you bring it to your data set. So you basically augment your data with this data set, and then you build a model on them and see how well it performs. So you're always experimenting, and it's completely a myth that you have the right data from the get-go. Now, I'm not sure if this answered your question, so please tell me if this answered your question. Now, Abaza, you have another question, right?
Yes, I have a follow-up question asked by Abanub at the end. That's okay. That's Site Noor, and also because there's not enough evidence that AI, and especially machine/deep learning, can transform your business as long as things work the way they are. Why change things?
Okay, so if I heard the question right, is there is not enough evidence that AI can change your business, so why change anything? Is that correct?
Yes, I think so.
So now it really depends on. This is actually one of the things that we work with a lot, and this is why we have actually very recently adopted an impact officer to measure the impact of artificial intelligence. Because when measuring impact, it's really interesting because most algorithms are judged on their accuracies, not on their impact, and accuracies can very much be confusing. So when you deploy a machine learning algorithm, you always have to see what was the case before you deployed it, and not how accurate is this algorithm, because sometimes you can bring in a very, very accurate algorithm and then nobody is using it and nobody is trusting the algorithm, because like change within the organization itself has to be coupled with the AI project. So if you deploy an AI and nobody ends up using it, there will be no impact, right? But if you deploy an algorithm and it's adopted right and it's experimented and it's being adopted like a bit by bit within the organization, then you can see impact. But if there evidence on how AI is changing businesses, there is a lot of evidence, of course, and we like within Synapse we have actually seen impact with many of our customers, and impact because we can use AI, for example, in a planning module where you're routing your fleet in a different way. So you're reaching your customers faster. You're for example reducing the time to market of your products and so forth. And measuring impact and measuring change is very, very tricky. So I guess you cannot like evidence of change and evidence of impact. Like many businesses have tried AI and it didn't work because maybe the framing was wrong and maybe it wasn't the impact wasn't measured in the right ways. But definitely measuring impact is key to
and also Ahmed.
And it's a mentality adopted whenever you're initiating or deploying.
Yes.
Yeah.
And also Ahmed, this has what Abanoob is saying is really hits the nail on the head, as they say, because this has been written about extensively in many books. But one of the recent books that I think we all read is Good to Great by Jim Collins. And one of the chapters is essentially that you are right, technology does not create the change, but it can accelerate it. But before you do that, you actually need the right mindset and you need the right framing and you need the right people on board that are convinced with the concept before you deploy. You can have the best, if you ride bikes, you can have the best bike in the world that, it's super light and it's super fast and everything. But if you don't have a rider, then it doesn't matter.
Exactly, and this is what I emphasize, because artificial intelligence is not actually intelligent. It requires still a pilot. It requires how you're basically framing the problem and how are you exposing your AI algorithm to the problem. And this where the data scientist mindset comes in heavily. So let's move on because we're a bit running out of time. So I'll go through the data types. So basically, what data?
So we have a couple of more questions.
So can you Abaza, can you let's take them at the end, because we need to go through the content and then we'll go to the questions right away. So when it comes to data types, we have like multiple forms of data types. We have labeled data. This is where basically you have data that's when we say labeled, it means that you know what you're looking for. So for example, sales predictions, you know that the sales of a certain SKU is already in the data and it's labeled like this is the target value that you want to predict. This is the target. I want to predict, for example, the sale of a shampoo, for example. So you have in your database the shampoo categorized as a shampoo and the historical data is there. So this is what we call labeled data. Unlabeled data is when you don't know what you're looking for. So for example, you have so many customers' data, right? You have thousands of records of customer data, and you don't really know the behavior that you're looking for, how you want to do a personalized marketing campaign, for example, and you don't really understand how these customers are behaving, what are the preferences, and so forth. So you just throw in the data to the algorithm, and then the algorithm would classify them into different classes. For example, if you're using, it's the most, I think, common case is with Google Ads, for example, when they say health fanatics or shoppers or media enthusiasts and so forth. So these are certain behaviors that are grouped together by an algorithm and then are labeled after the algorithm has classified them. And then comes the weakly labeled data. And weakly labeled data is very interesting because, for example, someone like Anghami or like iTunes, who are the famous application for music and so forth. Now, for example, they want to recommend you the music that adapts your taste, and you're listening to a certain type of music, and they recommend you, for example, a song for Shakira, for example, but you just press on the next song right away. So this is actually, we don't really know if you didn't like the song, or maybe you weren't in the mood, or maybe you just didn't want to listen to this song at the moment. But this doesn't mean that you don't like Shakira, for example. So weakly labeled data are labels that are not very much indicative of your preference, and sometimes this is a type of problem that has to be modeled differently. So these, when you speak about labeled data, unlabeled data, and weakly labeled data, we speak about the modality of thought that goes into the algorithm that you're building on these data types. So when it comes to types of learning on every data type, so for example, supervised learning, it's called supervised because you really know what you're looking for. So you want to predict the sales of a certain SKU. You do supervised learning by telling the algorithm that I'm looking for the number of pieces that I'll sell of this SKU. When it comes to unsupervised learning, you don't know what you're looking for, so you just throw in the data, and then the algorithm would get you out and spit out the different classes and the different segments that you need to look at. Semi-supervised learning has to do with sometimes when you have labeled and unlabeled data. So for example, like the music example, you don't really know, you like half know what you're looking for. So you know that you understand, you want to predict my preference so that you can recommend me the right songs, but at the same time your behavior with the songs is not really indicative of what you like and what you don't like. So some data pre-processing has to be done here, and a lot of experimentation has to be done here. Now, reinforcement learning is like the maze one. So it's a state-based learning. So for example, if you want to invest in stock markets, or you want to invest in, for example, house prices and so forth, basically what you tell the algorithm is that I want to maximize my portfolio. And based on the different states, based on the different actions, you either reward or punish the algorithm. So if it does a trade that put your portfolio down or make you lose money, you punish the algorithm. If it wins or if it gets more money, you reward the algorithm, and this is how it formulates its logic. So basically, the end-to-end process when it comes to deploying AI, what the data scientist does, they find the data, they collect the right data. They might not have the right accurate data at the beginning, and that's completely fine. It's an always evolving process. It's a never-ending process. You collect the data, you put it in an algorithm, you model the data, and see what happens. And this is a forever continuous process. Then you pre-process the data, in which sometimes, for example, algorithms don't really understand what Monday is. So they need to transform Monday into a certain number, like 001, for example. So this is a lot of the work that a data scientist does before going into algorithms and modeling. Now, choosing the type of learning algorithm. So is your problem a classification, a regression, a knowledge extraction, or a generative problem? And every one of these problems has certain algorithms to be applied in. Then you test and validate. So what they do here, they hide from the algorithm a data set. For example, your sales in November. You have your sales from January to October, for example, and you want to test it in November, and you already have the data for November, for example. So what you do is you test the predictions in November and see how the algorithm is performing, and then if it's performing well, then you put it into production. If it's not, then you need more optimization and more work on the data to be able to get the right predictions. And then it goes into deployment and integrations, and this is where a lot of software engineering goes into play. So how do you know if the work is successful or not? And this is actually the gentleman who asked the question that of the evidence. This is actually a very, very important question, and thank you so much for asking it, because at the end of the day, it's about business metrics. So if you deploy the best algorithm in the world with the best accuracy in the world, but it's not increasing your conversion rates, it's not increasing your sales, it's not optimizing your cash flow, or it's not saving you any money, then it doesn't matter at the end of the day, right? Then comes the model metrics. So the model metrics are basically what makes a model a good model and what makes a model a bad model. And this is a very a very important and a very deep domain that many people measure measure a model performance on accuracy, and it can be very, very misleading. And this is very important. I wouldn't go into it this time, but maybe in the next webinar we'll go into model metrics and how can you criticize a good model. Now comes generalization. How can your model be generalized on a bigger sample of the data set, on a bigger sample of the population? And this is very important. But usually it requires a lot of data augmentation and data work. So when it comes to the branches, like Marwan was saying, sometimes you don't have one model for all your branches. You build for every branch a model that works on it, on this behavior. For example, having a branch in Zamalek and having a branch in Masr al-Jadida or in London, for example, those two models behave very differently based on the locality of it, based on the population that lives near it, based on how accessible is it by foot, how accessible is it by car, what are the stores next to it. So all of this requires a lot of locality when you're optimizing your algorithms. Then you judge your algorithm based on speed, how fast it can predict, because for example a recommendation engine has to be extremely fast. If you're using it with an e-commerce website, you need to have the recommendation right away, otherwise it wouldn't be as beneficial. Now, another thing is explainability. So when the model gets an output, how explainable is this output? So basically you tell the model, why are you outputting this output at the end of the day? And sometimes based on the use case, explainability is very important. Other times it's not that important. For example, when you do facial recognition, sometimes you don't, if the model is can categorize the right faces as unique faces versus not unique faces, or returning faces, I'm sorry, then if it's classifying them correctly, then you don't really need to understand how explainable is it, or how it's doing it. And generally, anything that has to do with neural networks and advanced deep learning, explainability is a big issue, and people don't usually understand how it reached that output. Mm-hmm. But when it comes, for example, for investing or for SKU sales, for example, explainability means that why is this product selling better? Because it has better shelf visibility. It's in the summertime, so this is why it's selling better. So explainability is really an issue when it comes to the different use cases. Heuristics is, does the model make sense? So at the end of the day, when you apply a model like the online ordering app, if the store has CV, then there will be more likely to buy from this store. This can be a very, very accurate model, but it doesn't make sense, right? Because TV doesn't have anything to do with ordering online. So heuristics or domain expertise is extremely important when it comes to deploying an AI model as well. So I think we went through all like the big overarching part of this presentation. We're 10 minutes beyond our time, so I thank you everyone for joining in, and Abaza, if we can go very quickly through the questions, and we'll go 5 minutes through the questions, and if in the 5 minutes we can answer, we'll answer them by email. And I thank you all for being here. So Abaza, can you go through the questions?
Okay, so I'll start with the first one is a twofold thing. So how is the local market demand expected to change due to the coronavirus crisis? And in other words, how can you help businesses transform to adapt to the changes due to the coronavirus?
Very, very interesting question. And actually, this is still not yet figured out. But what we're doing here, like with what we're trying to do here is basically checking for variability analysis, the impact of how the consumer behaviors are changing, and then we can basically be able to frame models to do so. But at this point, honestly, in our experience, we still don't have a real case where we were able to change it all in the experimental side. But then again, we could see, for example, there is a rise, of course, in online ordering. People maybe who didn't order online as much are now using online ordering apps. So maybe this is the acquisitions of these customers are very valuable for online ordering and so forth. Though, how do we help businesses to change, to adapt? We're now basically we're trying to collect the right data, and we're trying to model the change as far as we can. But I don't really have an exact answer to this question, though I thank you very much for asking it. And if we reached anything significant, we'll probably let you know. Otherwise, currently what we're doing is we're trying to collect as many macro data as possible, like the CPI, interest rates, and all of that stuff, and trying to see their impact on the businesses to find any correlations by which the businesses can actually act and can be able to adapt and are able to adapt.
Okay, thank you, Ahmed. We have another question from Ahmed Abdul Hamid. He says that he's asking, can you please provide us with an application of AI/machine learning data science inside the construction industry?
Sure. So like a basic application is using, for example, computer vision to see for safety measures, seeing if the workers are wearing their helmets, are wearing their boots, if there are any violations of how they're handling construction equipment, if someone is not, if there are any defects, for example, in the construction site. This is actually some of the very, very interesting applications within the construction industry, as well as cost, for example, cost optimization and cost analysis, because costing and cost control is extremely important within this industry. So understanding the site demand, understanding the variability of procuring the material, and performing like the BOQs on the right times, with the right material and so forth. So all of these are basically applications of AI in it. And maybe you can also do, for example, you can predict the performance or the progression of your project based on the seasonalities, based on worker absenteeism, because like in Egypt, it's a bit common that we have a seasonality where workers don't perform as well as they do generally in the rest of the year. So all of this, so basically, like the overarching thing when it comes to construction is handling the variability and predicting the variability before it happens, so you can adapt and you can act on it proactively.
Mm-hmm.
Okay, thank you. I think we have. Yes, we have. The last question is, I would like to ask if you have ideas on handling uncertain labels within data.
Can you please clarify what you mean by uncertain labels?
Okay, we're waiting for the clarification.
I believe he means, Ahmed, like the Anghami and iTunes case when you're not really sure what to classify the data as. Is he not interested?
Yeah, okay, yeah. So basically what you do, this depends on a lot of experimentation and a lot of basically filling the gap. So for example, you can use for example, you can use what's called A/B testing, for example, and you recommend another song for Shakira, and if, for example, it's very, very frequent that whenever a song for Shakira comes in, they just move forward and they don't listen to it, then maybe Shakira is not up to their preference. You can actually use supervised learning as well in predicting if this behavior, if they like it or not. So maybe you can classify this person within a group, for example, who like Enrique Iglesias and who like Amri Diab and who like Lady Gaga, for example, and this group actually likes Shakira very much. So whenever you can see the common behaviors if they do the same, or maybe he just he just listens to Shakira at some point in time within the day. So maybe he likes to listen to Shakira in the evening and not in the morning. So it has to do, again, with basically the data feature engineering and data modeling and a lot of experimentation to be able to fill these gaps at the end of the day, and basically associate them with lookalikes. So you see what this person, who is the lookalikes in their class, and then see their behavior and try to basically associate their behavior with other lookalikes and see if.
And I think, Ahmed, it's good to end on a note where people, I think, should understand that it's not a sequential system, but it's more of a working in parallel system, and then experimenting with that and really finding the optimum path in every single use case.
Yes, exactly.
And Ahmed,
so as I said, like the key here, it's always a continuous process. It's always a continuous process of experimentation, collecting new data and trying new things. It's never ending.
Mm-hmm. Someone's asking, is it the same idea of a recommender system?
Yes, it's end of the day, it's a recommender system. So in the recommender system, you have basically, without going into the big jargon, you have content based and you have behavioral based, right? So content based this is a Shakira song. Behavioral based is you listen to Shakira, you listen in the morning, you listen at night, what other songs you listen to? Do you listen to the songs to the full extension of the song, or you just listen to a few minutes and then you go to the next one and then you go to the next one? This is a general behavior. So this doesn't mean you don't like Shakira. It's just your behavior as a person on how you deal with the songs, for example. So yeah. So I think this is it for now. We have passed the time with 15 minutes by 15 minutes. I thank you very much for being here. This is our first webinar. We'll send you a feedback form to fill in, and we'd like to hear your feedback on the webinar and what can we do better in the next one. Thank you all for joining in, and please stay safe, and till we see you in the next one.
Thank you, guys. Enjoy your day, and please let us know of any new topics that you also would like to have us covered.
Thank you.